So allow me invite Marc, who's going to talk to us about Tekton. Does the world really need another CI/CD pipeline? Marc,
Excellent.
the floor is yours.
All right, let's see if we can get this to work. And we'll do that. Excellent. All right, is my screen coming through?
Yes, I do see your screen.
All right, cool. Well, hello, everybody. I'll just check in every now and then with you, Emily, just to make sure I'm coming through okay, or if there are any questions. Yes, we're going to talk about this crazy open source project called Tekton, which Michael was just talking about, and we've just been throwing around the term CI/CD, continuous integration, continuous delivery, or continuous deployment. We're going to take a look at what Tekton is, why it exists, why maybe it shouldn't exist, why you might care about it, and why you might not care about it. So just really quickly, I'm Marc Hildenbrand. I'm in my Red Hat regalia.
Hello? Is Marc still with us?
I'm not sure. I'm trying to reach him.
Right.
Can you hear me now?
Yes.
Yes.
All right, cool. I'm not sure what happened there. Sorry about that.
All good.
All right. All
Still? All right, are you still able to hear me?
Yes, we can hear you.
All right, cool. Sorry for that hiccup. I'll I'll try and make sure I'll pray to the internet gods. But if we go too deep into this, yes, I'm with Red Hat. And if you want to get in touch with me, hopefully you can. If I'm still on the internet, if my connection stays stable, you can find me usually on LinkedIn, but also Twitter and all that other stuff. But let's get into it before my internet goes out again. So as we all know, and as Michael was kind of talking about, websites, for instance, are one of those things that don't just build themselves. Usually, if you're in good DevOps form, you have some sort of automated tool chain behind you, a CI/CD, continuous integration kind of chain. And it's not a new concept. And for websites like this one, this is the Pet Clinic website. Some of you who are familiar with Spring Boot would know this as sort of the hello world of Spring Boot websites. We're going to use this as a proxy for a real website. And as Michael was talking about things like shifting left and stuff like that, well, that's kind of what we want to do in any good CI/CD pipeline. So you may have noticed that grainy video in the background. Hopefully before I'm done, you'll hopefully see why I've used this grainy background. This is from the 80s. So let's call this guy Michael, because that was a popular name in the 80s. Let's pretend, despite his retro sensibilities, that he's a DevOps engineer of the new era. So he's big into knowing the benefits of having the best CI/CD automated CI chain that money can buy. One of the big tools out there, as many of you would know, is Jenkins. Probably if you've been in software at all for any amount of time, you would have come across Jenkins. And why not? It's open source, which means that it has sort of the collected wisdom of all the people who used CI chains that came before them, and Jenkins is free to use. It's trusted by the masses. Lots of people use Jenkins as a CI/CD tool, and you can use it to build just about anything. And sort of my favorite story about what you can build with Jenkins is a friend of mine that I used to work with used Jenkins to build Jenkins agents in a sort of inception kind of things. Jenkins was kind of building itself like a nanobot crisis. This is Jenkins Blue Ocean view. So this is just showing a typical kind of Jenkins pipeline. And this is a pipeline that I might use to build this Pet Clinic website, or more specifically, Michael might use. And it has some of the things that Michael talked about, some amount of static analysis. Of course, this isn't necessarily a Sterling DevSecOps pipeline, but it shows kind of general DevOps kind of principles in there where you're archiving images and you're building them, and et cetera, et cetera. Now, you may have noticed that there was a part of my pipeline that had something about building an image. And this makes it look like our website might be running on Kubernetes, which, full disclosure, there will be some Kubernetes in this as mediated by Red Hat's OpenShift. That's just because what I could get, it's the cluster I could get my hands on quickest, so this isn't really about OpenShift. But let's meet Jessica. Jessica's gonna, by the way, that's another popular name from the 80s. Jessica represents the continuous delivery side of the
We really have a bad network.
Yeah.
Um,
Hello, can you hear me now?
Yes. You're back.
Sorry, I'm
That's good.
not sure why it keeps on clipping out, but the second I notice it, I'll come back.
Yep.
So I can, the funny thing is I can hear you guys.
Oh, that's cool. Okay.
Yeah. All right. Cool. So we're back online, yeah?
Yes, yes,
Okay,
you're back.
great.
Yeah.
So what I was saying before the connection dropped here is that Jessica's all about Kubernetes, continuous deployment. And some of the things that you can do with Kubernetes, as well as other platforms and things that are modern CI/CD, is that you have zero downtime, right? You want to be able to roll out quickly. You can do things like A/B testing. You can handle things like blue-green environments. And she loves Kubernetes for that. Why does she find it so finger-licking good, as you saw in the previous slide, which isn't really great in these COVID times? One thing that makes Kubernetes so good, this continuous deployment, is the notion of immutable containers. So the immutable nature of these containers means it's easy to kind of deploy them and keep them highly available, scalable, elastic, unlike my internet connection. Infrastructure as code. So Kubernetes, for those of you who aren't familiar with it, is a sort of declarative kind of platform. So it has a control loop, and basically you talk to it using YAML files. You can almost think of it as like a built-in kind of Terraform in terms of building a platform or building different environments where you deploy your containers. And with the help of an open source project called Knative, it can do Lambda-like stuff, so serverless kind of functionality where your containers can be spun down to zero if they're not being used for efficient use of compute resources on your Kubernetes cluster. Now, for those who are used to using Jenkins as an eminent CI/CD chain, Jenkins itself is not really built for the world of Kubernetes. It can work in Kubernetes. It can be run inside of Kubernetes. It can be run outside of Kubernetes. But either way, there are a few reasons why using Jenkins, particularly if you're deploying into Kubernetes, might not be ideal for our friend Michael. For one thing, and I won't go too deep into all this, but there's just a couple things you have to think about with Jenkins, especially when you're in Kubernetes land. One is that it tends to be monolithic, which means it needs to have a master, and it has a bunch of different build agents. So while you get some amount of, only scale up the build agents when you need them, particularly in Kubernetes, you always need a central master, which leads to other problems like it being difficult to isolate. If multiple projects are running through the same master, they're all going to start to use different plugins. Again, those of you who've used Jenkins. It's not highly available out of the box, meaning you have one master server or you have to replicate that master server. It becomes a separate platform. So whether you're running Jenkins, if you're running it inside Kubernetes, it's a platform in a platform. And some other kind of annoyances, particularly for those of you who may be dealing with Kubernetes-based deployments. And as we were talking about just before with DevSecOps, additional security concerns may be introduced through the Jenkins platform itself with different plugins that may not be safe, and you have to consider patching those along with your Kubernetes platform itself. So can there be a better way? Well, let's see if the internet will allow me to show you how there could be perhaps a better way deploying in Kubernetes.
Chocolate.
Peanut butter.
Hey!
Oh, hey, you got your chocolate and my peanut butter.
Peanut butter on my chocolate.
What?
Delicious.
Two great tastes that taste great together. Reese's Peanut Butter Cups. Real milk chocolate, delicious peanut butter.
Reese's Peanut Butter Cup.
So I grew up in the 80s in the US, and you can find that video on YouTube if you want. Just before I go too deep into it, The comments are hilarious, so I commend that to you. Take a look out for this peanut butter cup commercial from the 80s in the US. Now, why did I hit you over the head with this 1980s kind of trope of this Reese's peanut butter cups? So if it's not already clear, when you think about Tekton, Tekton is sort of, you start with the peanut buttery goodness of Jenkins in terms of its ability to do continuous integration. You add to it the continuous deployment, the kind of platform level sensibilities you get from Kubernetes, and you wind up with Tekton. So this kind of Kubernetes native CI/CD, or Tekton is basically, if you want to dazzle your friends with the knowledge of Tekton, it's basically you got Kubernetes all in my Jenkins. That's how I'd sum up Tekton, which leads to some things, just like a peanut butter cup is more delicious than just chocolate or peanut butter on its own. Tekton has, especially when used with Kubernetes, has some benefits that are greater than the sum of its parts. Those who are familiar with Kubernetes, Tekton is built in an era where it knows Kubernetes exists, so it leverages existing Kubernetes primitives for it to be able to do its work. So it knows about the role-based access control, and it leverages that, as well as how Kubernetes makes use of its compute resources. So there's no need for a central master, for instance. Everything is written in YAML. In fact, for those of you who know about Kubernetes, Tekton is implemented as a number of custom resources, which is a way of extending the Kubernetes API. So you can basically install Tekton into your Kubernetes cluster and secure it like you would anything else you install into your Kubernetes cluster. And because it's custom resources, it means it follows a similar upgrade path for Kubernetes. So it uses containers behind the scene, and we'll see why that's important. But it means whatever security processes you have in place to secure Kubernetes, you'll kind of get that for free out of the box with Tekton. So there'll be some canned demos for this, again, internet gods notwithstanding, and we're going to take a look at a Jenkins pipeline translated into a Tekton pipeline. So the two seem very similar. What you see on the left is a blue ocean view of Jenkins, and what you see on the right is the same CI/CD pipeline as reimagined in Tekton with a UI called OpenShift pipeline. So this is Red Hat's wrapper around Tekton. So if we go a little bit deeper into Tekton pipelines, I'm going to point out certain features that are chocolate and peanut butter important, and these are the features that you might want to care about Tekton. So these are the features that might make Tekton stand out and why people thought the world might need another CI/CD chain. I might skip through this quickly. It's just kind of talking about where Tekton fits in the Kubernetes stack. That's not super important for us today. What I do want to talk about is this part, this purple bit on the right. This kind of gives you a sense of sort of how Tekton is conceptually built. And it all starts in the center with this notion of a pipeline run, which if you are used to Jenkins, you have a pipeline run in Jenkins, like an instance, a run of a defined pipeline. And that's the same thing in Tekton. And above this box is sort of the class definition, if you will, of a pipeline. What is a pipeline? Just like you might define a class for those who are programmers out there, and this represents an instance of a class. And then below the pipeline run are all the other things that instantiating a pipeline run winds up creating at runtime when it actually is trying to integrate. So pipeline runs are also a way for us to say, if I have a defined pipeline, just like when I instantiate a class and I might give it certain variables and parameters in its constructor, I can do the same thing with pipelines in the form of resources or parameters or workspaces. That's what Tekton calls it. So we'll get into that a little more in a second. Again, this is what a pipeline run might look like as visualized. So this is the definitional way of looking at a pipeline run. So a pipeline is just a way of ordering tasks. So a CI chain is usually a number of tasks that have to happen in some directed order. And all a pipeline does in Tekton is just define what the order of those tasks are, as you see here. It means that you don't need to really worry the order of the tasks. You just need to define which tasks need to run before which other tasks. And Tekton handles the rest. And it only runs whichever tasks need to be run or whichever tasks can be run in parallel. It sorts that all out for you. A pipeline also does some work to map whatever you said, whatever inputs you gave, to underlying other reusable bits called tasks, which I've talked about. We'll talk about them a little bit more. Pipelines can be reused across projects, but the main thing that gets reused in Tekton land, and one of the first features that's most important about Tekton, is this notion of a task. So the task is sort of like a building block of a pipeline. It's the composable, shareable unit of a pipeline. An example might be if I have a task that allows me to check something out of Git, or create a pull request in Git, or run static analysis with something like, I don't know, SonarQube. These are all examples of a task that could be composed or reused in pipelines based on different parameters. Tasks can also, they can have outputs. So when I check something out, maybe an output is, hey, I want to know what directory this checked out to. So a task can feed outputs into the next task as governed by a pipeline. So you can kind of see how you're starting to build together like Lego bricks. Inside a task, you define steps. We'll talk about steps in a second. Steps are just an ordered execution. There's no crazy graph there. It's just step 1, step 2, step 3. So you can't do anything in parallel. You just run sequentially through them. And tasks can, fun fact, be run independently of pipelines, almost like a cron job, for those of you who are used to that. Some other example tasks that you see, you can find in a task catalog. So Tekton is open source. It's a project that sponsored by Google and Red Hat and others. And what Tekton is doing is creating a giant community of people who are creating reusable tasks that they share with the internet. Some examples are things that use Kaneko, use source to image for things like Java and Python, language specific ones like running Gradle or NPM or Maven. So you can see these here. And if I can make the slides available to you, you will have links to all these things if you want to check these out yourself. This represents a task, which is just a Maven build for those of you who know and love Java. So let's just take a quick look at what that looks like in practice. So this is something I recorded a little earlier. So this represents a pipeline. So on the bottom is the Blue Ocean pipeline, and on the top, and I'm sorry if it's a little bit small, I can't zoom in at this point, that's the OpenShift pipeline. Now you see, here are my tasks, checkout, set build version, and here are my parameters to that task. So, and then here is how I map those parameters to my tasks. This is all written in YAML. We're looking at the YAML here. Here's the git clone, and you can see the parameters that come into git clone, almost like it's a function. So I take parameters from here and I map them into my task, which doesn't know a priori what pipeline it's part of. Every step has a container, and then you say what you want done inside of that container. That's how you do the different steps. And then I can have another build version over here. So this is another task that doesn't know what pipeline it's in. It's the pipeline that maps inputs and outputs to the task. So just for the sake of time, I'm gonna skip the rest of that for now. So you kind of get the idea of how each of these tasks are composed in YAML. So Emily, I'll just check in quickly, make sure you guys are all still there, and I'm not talking to nobody because of my stupid internet. Everything's still coming through okay?
Yep, all good.
All right, excellent. The next thing that is super important about Tekton, so thing number 2 that you should remember about Tekton is that it allows you to run anything you can run in a container can now be part of your CI/CD pipeline. So whether that's something that's commercial off the shelf, some sort of impenetrable container that you have no ability to change, or whether that's a container you just write yourself. For those of you who are familiar with Kubernetes, this is a big deal because it means anything else you're doing in the Kubernetes cluster, anything else you can do with a container or a pod, you can do with a step in Tekton. So you can pass it environment variables. You can have it mount volumes, which is like block storage. For those of you who know like AWS, it's like EBS. You're gonna have config maps, secrets. It's basically, for those who know Kubernetes, this is a very powerful way to execute builds. Maven is one example of that, as we talked about, but another one is some of you may hate things like Bash if you find yourself in Linux land, and you may really like Python. Well, now you have an ability to run arbitrary Python. And again, Should you? I mean, there's some security issues in here as well, but you can run arbitrary Python, not just security, but just maintainability issues if you're always running arbitrary Python in your build steps. But you get the idea. You're bounded by your own imagination and conscience. When we talk about a pipeline run, as I mentioned, like a function or like a class instantiation parameters, there are different things you can pass in. They come in three categories, three flavors. One are pipeline resources. And remember, this pipeline metaphor is meant to be about, I put something in and I get something out of the pipeline, continuous integration kind of pipeline. Inputs tend to be things like, oh, a Git repository, like some sort of URL of a Git repository. Outputs might be an image that's been created, you know, by way of build or Docker build or some Kaneko, something like that. Parameters just adjust how a task is run. And workspaces are volumes that can be provided, right? So again, elastic block storage if you're in AWS land. One thing I should point out, Tekton is still in beta. It's coming ever closer to, you know, general availability, but there's some things in flux, and pipeline resources are something that may be going the way of the dodo because it turns out parameters and workspaces are generally enough for the community. So just keeping it real for you guys. Task run. Remember, I said a pipeline instantiates about, once you instantiate a pipeline run, it in itself creates things. And this is important because this is Tekton making use of its knowledge, being contemporary of Kubernetes. It knows that Kubernetes is underneath. So when it executes its tasks, for every task that can be executed in parallel, whether it's one or multiple, at that stage of the pipeline, it'll spin up a pod. So a pod in Kubernetes is just containers that run closely together. They can share network address space, they can share volume mounts and stuff like this. So task runs are just these tasks run in a pod. The steps all run in a pod. And again, for those who care about Kubernetes, there's a whole bunch of other kind of cool Kubernetes things you can do because they're just pods. And to illustrate that point, we'll just take a quick look over here. So let's pretend what you're going to see here, oh, and it's so small. I'm sorry. I hoped I would be able to zoom in on this, but I can't. But I'll just kind of tell you what's happening here. We have three buckets, which we'll get back to in a second. When you take a look at these pipeline runs, so I've kicked off a pipeline and it's running checkout. What you see here, this represents the pod that's running, and this represents pods that have finished. And so what you see on the left, tasks and steps, and what you see over here are pods and containers. So this is a pod and a container that finished. And here you see, oh, the task is set build version. The pod is this crazy Kubernetes name. And then when it finishes that stage of the pipeline, it moves over to the right. It's a completed pod in Kubernetes. So as time goes on, as it's busy kind of building our project, and you can kind of see it's logging just like you'd expect it to log as it's running Maven. There's also a CLI that's provided all the way on the left, which you're about to see. First, I'm going to show, hey, they're really custom resources in Kubernetes. So this is OC is like kube control. So it's just showing you that, hey, you're running some sort of pipeline. And then Tekton provides a CLI that abstracts away Kubernetes a little bit and allows you to look at the logs of your pipeline. So it allows you to act at a higher level of abstraction. And as you see, as time goes on, more and more pods move over here. For the sake of time, I'm going to just scrub through this. You go through your build. The only other thing I point out is notice that these two tasks are running in parallel because the graph told it could. Unit tests and code analysis were shown to be something that can be done in parallel. So Tekton scheduled those two pods to be run in parallel, as opposed to maybe having one agent that takes up all the compute resources and all the memory, at least for the time that it's running. And that's the basic idea. If we go to the end of this run, so when it finishes, just again, for the sake of time, I won't go too deep into this, but Tekton doesn't have a master, as I said. It needs a host, and Kubernetes is its host. So for things like triggering, telling people, oh, hey, I'm ready. Do you want to deploy something to staging? Or do you want to create a pull request? Or do you want to merge a pull request? It needs to leverage things that already exist. And what you saw go by was a Slack message What you see here is Tekton using a Nexus repo to store a Surefire report, right? To store sort of a unit test report. Whereas in Jenkins, that's already built into the master. So you get some benefits there of having a master and a kind of cooler UI. So again, for the sake of time, I'll skip past some of that. And just quickly, we're just about done here. Just talk a little bit about, some of you may be saying, well, wait a minute, Jenkins does a lot of other things. Like, what is Tekton so on about? There are other things that Tekton does that we don't have time to show. It has a notion of conditions. For those of you who've used Jenkins pipelines, you can hook up metrics to see what kind of resources and just general introspection, observability about your pipeline. It also can emit events, open source based CNCF level cloud events, which are just open standards for how events are generated. And you can have other things in your Kubernetes cluster hook into those events as different parts of your pipeline finishes. One cool bit, like you saw with Slack, is there's a sister project that's bound together in Red Hat's pipelines project, but this is called Tekton Triggers, which is like webhooks, Git hooks on steroids. So you can basically have Tekton respond to any input as long as it comes in as JSON. And it gives you some ability to munge any input that comes in, whether it's XML or form URL encoded, into something that looks like a JSON document and allows you to connect it to existing pipelines in your cluster. And also we saw briefly the Tekton CLI that kind of abstracts away some of the underlying Kubernetes for you, so you can reason about Tekton at the CI/CD level. So to quickly give you just a sense of some things that are possible with triggers, let's.
Uh-oh.
Me. Can you hear me?
Yes, we can hear you now.
Sorry about that. I don't know why this keeps on happening, but we're back. So this last bit that I want to show you is just about how you can connect Tekton to other tools that you have out there. Again, because you can just run any container, you can run arbitrary code. So what I'm showing here is how I just used a Slack webhook to trigger a notification to me when my Tekton pipeline was done, which allowed me to set up links to be able to look at the pipeline run and inspect it. And it also gives me an ability with Slack interactivity, the interactive components. Here's my pipeline of one task, which is promoting to staging, and my kind of made up example here. And if I click that button, it'll trigger that pipeline. So again, showing that I have a webhook that can listen to any kind of endpoint that I so choose, allowing me to trigger things to staging, which is what you kind of see there. Just one quick thing about Tekton before we're done. There's this notion that one of the Google talks on Tekton, they talk about this notion of the plumbing and the porcelain. Tekton is very much about the plumbing. It's about, hey, I want to give you all the tools I can or we can to help you build whatever you want. But it's not necessarily user-friendly, as you saw, just as it is. All those YAML files, some of you who are more developer-minded may be allergic to YAML, and I don't blame you necessarily. Something like a Jenkins is both user-friendly, gives you some more better UI coverage, but also has some of the plumbing underneath it, allows you to build almost anything. There are products out there, Jenkins X is one of them, that leverage Tekton, and they put a porcelain, if you will, sink on top of Tekton. OpenShift pipelines, which you saw a little bit of in this demo, that's another example of the kind of UI on top of something like Tekton. And then to wrap up, so is Tekton the future of CI/CD? Well, if you don't use Kubernetes, no, it's not. You can probably just stop right here and say chocolate and peanut butter, Tekton is Jenkins and Kubernetes, and leave it at that. Right now, I would not recommend you look at Tekton at all, unless you are building and working in a world of Kubernetes, in which case it may be worth your taking a look at it. But remember, it needs a Kubernetes host to run. Nobody is going to be running Tekton standalone, so far as I've heard. Again, remember the plumbing and the porcelain. Tekton itself needs a UI. And again, OpenShift Pipelines, Jenkins X, these are two examples of CI/CD systems that leverage Tekton underneath and make it a little more visual and easier to implement. OpenShift Pipelines, for instance, gives you a graphical UI for creating those tasks and pipelines, as we talked about today. And finally, because Tekton is still in beta, it's not yet really considered a GA project, so it's a little bit cutting edge, though it's very close to being GA at this point. But yeah, remember pipeline resources? They're going away, maybe, who knows? So that's what it's like to be in beta. There are some resources, if I can share this slide, or Emily, if you do it, or we do in the Slack channel, you've got some information on this. And thank you for your time. Sorry for the internet. I don't know what that internet bugbear was all about, but glad we made it to the end here. Any questions?
I just say that it was quite cool, and I would like to take a look, because yeah, I found that bit about bringing up the infrastructure and monitoring the pipeline in your IDE, and I can look at the logs, and I can also see how tasks are progressing. So I think it will really improve the developer experience if you want to get into that zone. So I think it's really cool. Yeah, thanks for the demo. Yes, that is cool. Yeah.
Excellent.
Is there support for like Helm?
Yes. So remember, because you can do anything in a container, so Tekton can run Tekton commands in a container, as well as arbitrary kube control commands. So it could run Helm, and it could run, yeah, it could do a Kubernetes, kind of install an operator that may run Helm, or it can run Helm directly, just as long as it runs a step, which is a container that has Helm installed. But the cool thing is it's doing that within the context of the cluster, right? So it's the internal network to the cluster.
Right.
Yeah, so that's some of what makes Tekton cool. Sure, you can. The only problem is, ooh, it may be some work, but somebody may have done it before. So check the Tekton catalog. Yeah.
Cool.
Other questions?
Ray, I think. Has said, I've got one. Easiest way to set it up on a cluster? Helm chat. I'm not sure whether that's a question. But
yes, Helm, you can set, I think you can set up with Helm. If you go to the Tekton kind of open source project, it's usually like one YAML file that you need to kube control, apply, blah, and it sets up Tekton for you. Normally it's installed as an operator, which is sort of like, it's like how, you know, RDS sets up databases for you in AWS. An operator kind of does that on a Kubernetes cluster for pick a thing, whether it's a database or in this case, a pipeline system, a CI/CD pipeline. It also integrates with Argo. Those of you who may know about GitOps and Argo CD, we didn't have time to go into that today, but Tekton works very well with Argo CD because it can create pull requests, or it can trigger Argo, either or. And then Argo can do the actual deployment side, limiting Tekton more to the continuous integration.
Can Tekton be installed in Kubernetes cluster other than the one being targeted for deployment?
Yes, yes, it can. In fact, for those of you who use Google Cloud, there are a lot of Tekton, there's a lot of Tekton functionality that's unique to Google Cloud. And one of the, I believe it's an output as well as an input, is a Kubernetes cluster. So Tekton was designed assuming that it would manage other Kubernetes clusters, creating them, destroying them in, you know, well, hopefully not destroying them in a destructive way, in a controlled way. But it was set up to be able to orchestrate Kubernetes clusters or work on Kubernetes clusters as well. But remember, it itself has to run in a Kubernetes cluster itself.
Anchor says, thank you for that response.
Cool. I hope I answered the question.
Awesome. Do we have any more questions? Okay, so somebody has said thanks, Mark. That was an awesome presentation.
Cheers.
All right. So at this point, I think I'm going to stop recording.